When we study acids and bases, you have a couple of different equations that you need to learn to use, when to use them, and what they give you. We have a couple of different variables. First one, we have pH is negative log of a hydrogen. There's two variables there. You have to find the log button on your calculator. You just need to push it. You don't need to totally understand what it's doing, but we will talk about that later on. So if you have the hydrogen concentration, you can solve for a pH. And then when you rearrange this, it looks like the hydrogen is 10 to the negative pH. So we give you both versions of that equation, depending on if you want to solve for pH or hydrogen. We also, since we're going to look at hydroxides as well, we can have a separate version of this that's the very same thing. pH is negative log of the hydroxide. And then if I wanted to rearrange it, I could say the hydroxide is 10 to the negative POH. So we keep our base particles with a POH, and we keep our H's together for pH. pH is the one that we traditionally look at because we have a pH scale. Then in addition to that, we have the hydrogen and hydroxide molarities are related to each other by Kw. And this is the constant for water, 1.0 times 10 to the negative 14th power. That tells you how the concentration of those two ions break down and compare in solution. And if you catch that at 10 to the negative 14th power, it's actually related to this 14, where we take the pH, which is a function of that, the POH, which is a function of that. pH and POH equal 14. Okay, so these are the equations you're going to use, but if you would like a tool to help you navigate them, we have the acid-base block. This is just a quick reminder to show you how everything is related and what equations can help you go from different spots on this block. If you have a hydrogen molarity, we know that the hydrogen is related to pH. Those are both hydrogens. So I can calculate back and forth between pH and POH using either the negative log equation or the 10 to the negative pH equation. So that'll let me go back and forth between these. If I have a hydrogen, I know it's related to hydroxide with water, so I can use Kw to go to hydroxides. The hydroxide particle is a base. That's going to be related to my POH, and I can go back and forth between these using my log equations, negative 10 to the negative POH and negative log of the hydroxide. And then pH and POH are related with our pH scale equation. pH plus POH equals 14. This is a nice little map that shows you how to navigate the pH, POH, hydrogen and hydroxide molarities and which equations to use. It's a good visual rather than just having a list of equations and not always knowing where to go. This at least lets you show which variable is related to which other ones and what you can do about it. So here's the acid-base block to help you with your pH calculations.